Okay, alcohols and carboxylic acids, worksheet 1. So we talk about which of the following is the general formula of an alcohol. So you have to recall that general formula is CnH2n plus 1OH for alcohol. Okay, so if you recall this, you just need to spot the answer, and the answer will then be B. Okay, straightforward. Next one, question 2. So we have compound M, they give you a structure, and they ask you which of the following is the oxidized product. So first of all, what is this? This is C2H5OH, okay, meaning this is my ethanol. Okay, ethanol. So what happens when ethanol is being oxidized? So when ethanol is being oxidized, we get ethanoic acid. So they ask you for the oxidized product. That means what happens when this M is oxidized. So when this M is oxidized, what we get is ethanoic acid. Ethanol to ethanoic acid. So our answer would then be A. Okay, so read your question carefully. Next one. Question 3. Which of the following is not a use of ethanol? So based on your notes and your reference book, ethanol has 3 uses. Ethanol is used as a fuel. Ethanol is a constituent, that means it's a main substance in alcoholic drinks. It's also a solvent, example to use for paint thinners and so on. Is it a flavoring? No, it is not a flavoring. So B is not a use of ethanol. Okay, next, question 4. Which one of the following statements about fermentation is true? So when we talk about fermentation, we are here talking about glucose, which is your sugar, in the presence of yeast at 37 degrees Celsius, forming your ethanol as well as your carbon dioxide. So when you see the word fermentation, you must remember of this reaction. So let's see which statement is true or not true. So A, carbon dioxide is produced. So yes, it is true because the products is these two. B, fermentation proceeds best at this temperature. No, it is not true. Fermentation proceeds best at 37 degrees Celsius. Enzymes are found in glucose solution. No, it's not true. Enzymes are found in yeast. Fermentation works well under sufficient sunlight. Not necessary to have sunlight at all. So, which is true? A is true because carbon dioxide is produced. So, A is true. Okay. Next question, which change cannot be achieved by a single chemical reaction? So, we look at the first one. How does ethanol become ethanoic acid? It is by oxidation. Okay, either by bacteria in the air or by adding an oxidizing agent, for example, potassium manganate. So this is one reaction, oxidation. Ethanol to propanol, you have not learned this at all on how it can proceed. C, alkene to ethanol. Okay, this is an alkene. What we do here is adding of water. This, however, is out of syllabus. So this is just for your information. Okay, but this is a single reaction called hydration. Next one, this is the same as the previous question. Glucose to ethanol and carbon dioxide. This is the process of fermentation. So A, C, and D can be achieved by one reaction. However, B cannot. So B is the answer. Okay, next. Which compound can be oxidized to propanoic acid? So, how do we get propanoic acid? Propanoic acid must come from propanol. Okay, so propanoic acid must come from propanol. So the question would be, what is the chemical formula of propanol? So if we do a recap, Okay, for our alcohols, this is our general formula CnH2n plus 1OH. For n equals to 1, we call it methanol. N equals to 2, we call it ethanol. And n equals to 3, we call it propanol. So if n equals to 3 is propanol, C3, so it will be C3. 2 times 3 is 6, 6 plus 1 is 7. So C3H7OH. So you must memorize the general formula by heart and know that propanol for alcohol is N equals to 3. So C3H7OH, which means that our answer would be C. Okay, so here is clearly written for you, C. Okay, next. Alcohols from a homologous series, name a characteristics. Homologous series has many characteristics. One of it, for example, is they have the same general formula. There's many others like the same functional group, like the members differ by a CH2. Okay, so there's many others that you can write down as well. Okay, so name the second member of the alcohol series. So again, back to this. My first member, my second member. So my second member, the name is ethanol. They say name. Okay, so ethanol. Next one. Part B. One of the alcohols contains 3 carbon atoms in each molecule. Draw the full structural formula of this alcohol. So they say 3 carbon atoms. Alcohol. So for alcohol to contain 3 carbon atoms, N must equal to 3. So we're talking about propanol here. So we're talking about propanol. So propanol will be C3H7OH based on the general formula CnH2n plus 1OH, where N equals to 3. Okay, so now that we know is this, how do we draw? First of all, we always draw our 3 carbon. So we draw 1, 2, 3. We join them up. Then now we have H7. So always at one end, we draw our H. So we have 1, 2, 3, 4, 5, 6, 7. That is our hydrogen. H, 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 H. Then we have our OH, our alcohol, so dash O. Okay, this is our structural formula. So all the bonds, we need to draw it out. So O dash H. Okay, so this is the structural formula of alcohol. Okay, next. So we talk about homologous series. We talk about the change in the physical properties as they increase in molecular size. So first question says, how does the boiling point of an alcohol with 3 carbon atoms compare with 2 carbon atoms? So if you remember the trend, 3 carbon atoms is bigger in molecular size, the boiling point would increase. So we have to state clearly, the alcohol with 3 carbon atoms has a higher boiling point. Because they ask you to compare. So state it clearly. Okay, suggest a possible explanation for this difference. So here we got to talk about as the size of the alcohol molecules increase, forces of attraction between the molecules increase. Because they are very attracted to one another, more energy is required to break these forces of attraction, which is why the boiling point becomes higher. Okay, next question. Which 2 compounds are formed when an alcohol burns in excess air? So like we talk about burning, combustion, whether is it alkane, whether is it alkene, whether is it alcohol, all the products are the same. So when they say excess air, we're talking about complete combustion. Okay, so here we're talking about complete combustion. So if it's complete combustion, there are 2 products formed, which are also compounds, carbon dioxide and water vapor. This is for complete combustion. Okay, next. This question is talking about fermentation. Okay, and it tells you to write the chemical equation for the formation of ethanol from glucose and state the optimum temperature. So we are back to fermentation. So before we write that out, you must first know what is fermentation. So fermentation is our glucose becoming our ethanol and our carbon dioxide in the presence of yeast, and it has to be at a temperature of 37 degrees Celsius. Okay, so now we know the temperature. Now we look at the chemical equation. So glucose, the formula of glucose is C6H12O6. Okay. Then we draw an arrow. The formula of ethanol is C2H5OH. Again, if you forget, you can go back to the general formula, CnH2n plus 1OH. And ethanol will be N equals to 2 because methanol and then ethanol, then propanol. So N equals to 2. So you get this formula. Carbon dioxide will be carbon. O, di means 2. So it's carbon dioxide. Okay, then the next step you need to do is you have to balance the equation. So to balance the equation, we have carbon and hydrogen. So we can count our hydrogen first. There is 12 hydrogen here. There is 5 plus 1, 6 hydrogen here. So to make it become 12, we should put a 2 in front. Okay, so once we have that, 2 times 5 is 10, plus 2 is 12. So our hydrogen is balanced now. Now let's check our carbon. So if there's 6 carbon, here is 2 times 2 is 4. So 6 minus 4 would be 2. So I should put a 2 here. Okay, then we check our oxygen finally. So we have 2 oxygen and 2 times 2 is 4. So 4 plus 2 gives me 6, which is the same as this, which is 6. So this would then be my balanced chemical equation. Okay, so we'll write it in. C6H12O6 2C2H. Optimum temperature 37 degrees Celsius. Okay, then let's see the next part. Describe how you would test for the colorless gas. So the colorless gas that is being produced is carbon dioxide gas. So how do we test for carbon dioxide gas? Okay, so same thing. We test for carbon dioxide gas by bubbling the gas through lime water. And what will you see? You will see a white precipitate form. So this is theory. You've got to spell out the whole word precipitate. Okay, so this is how we would test for it. Okay, then next. Give a reason why fermentation must be carried out in the absence of oxygen. And write the balance equation of the reaction when ethanol is exposed to air. So this part is talking about fermentation. There is a condition for fermentation where there is no oxygen. We cannot have any oxygen present. Okay, we must make sure there is no air. And what is the reason? Okay, the reason is because once your ethanol is exposed to oxygen, it will be oxidized, and instead what you get will be ethanoic acid. Okay, so this is what will happen. So first we describe what will happen because they say why. So we describe it by saying if ethanol is exposed to air, it will turn sour due to the bacteria in the air, and it will oxidize ethanol to ethanoic acid. Okay, then now we talk about the balance equation. So our ethanol is C2H5OH. Because this is bacteria in air, we put O2. Ethanoic acid is CH3COOH. And remember, you get water vapor as well. Okay, in case you forget how to do ethanoic acid, go back to the general formula of acid CnH2n plus 1 COOH. Okay, for this acid, this is acid. Acid is a special case. N equals to 0 for methanoic acid. So for ethanoic, N equals to 1. Okay, so because N equals to 1, that's where we get this formula for ethanoic acid. Okay, then now once we have this equation, we got to check if it's balanced. Okay, so the equation is already balanced, we just need to write it down. C2H5OH plus O2 to give you CH3COOH plus H2O. So you can count and check. 2 carbon, 2 carbon, 6 hydrogen, 3, 4, 5, 6 hydrogen, 1 plus 2, 3 oxygen, 1, 2, 3 oxygen. So this equation is a balanced equation. Okay, next, what is the advantage of using ethanol as a fuel? So it is less volatile than petrol, less likely to explode. Okay, next question. Write the names and molecular formula for the second and third member of the alcohol series. So go back to this again. Okay, we talk about alcohol series. So this is the general formula. They talk about the second and third member. So this is my second member, ethanol and propanol. Okay, and this would be my general formula. So first of all, let's write ethanol first. And then let's write propanol. It's my second and third members. So ethanol is N equals to 2. So C2H5OH. Propanol is N equals to 3. So C3H, 3 times 2, 6, 6 plus 1, 7, OH. Okay, so this is the name, this is the molecular formula. Then they ask you to draw the structural formula for ethanol and propanol. Okay, so we'll move to the next page. So ethanol was C2H5OH, propanol was C3H7OH. So always draw our carbon first. So C, we have 5 hydrogen, 1, 2, 3, 4, 5. Okay, so H. Then we have our functional group OH, so dash O dash H. Next one here, 3 carbon, always draw your carbon first. Each carbon must have 4 bonds, so we can count 1, 2, 3, 1, 2, 3, 4, 1, 2. This one here, we leave it for the functional group. Okay, so we write down our 7 hydrogen, 1, 2, 3, 4, 5, 6, 7. Then your functional group will come in, dash O dash H.